Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and today we will be presenting our project on machine learning for a movie recommendation system. This project is part of our course for special topic in computer science CSC649 and was prepared under the guidance of Professor bin Ahmad. Our team member consists of MOHAMAD Nabil, NURUL Nabilah, FARAH HANIS and me ULFATUNNOOR. Here is the outline of our presentation. Introduction, purpose statement, objective, scope, significance, coding section, result, discussion, recommendation, and conclusion.
Hi, my name is FARAH HANIS with AZMY. Today we will look at the interesting area of movie recommendation system and how they impact on the user experience. Sophisticated machine learning algorithms known as recommender systems are implemented to provide users with personal recommendation, including movies, music, products, and other content. In order to provide personalized recommendations, this system analyzes a variety of user data elements such as information regarding demographics, ratings, and viewing history. The user experience is not only enhanced by this personalization, but it also increases user satisfaction and engagement by providing relevant and engaging suggestions. So, personalized recommendation systems are essential for enhancing the user experience by offering customized movie recommendation systems that are based on the preference and sentiment of the individual. It can be quite difficult to identify movies that are in alignment with the specific requirements of users. Given the harsh amounts of movie options that are currently available, our project aims to develop an effective movie recommendation system by utilizing a movie dataset from Kaggle to resolve this issue. Next, we move on to the three problems that our team identified for this project. The overwhelming variety of movies available on streaming platforms in the current digital era can make it difficult to users to select content that meets their needs. This leads to an amount of significant issue. Actually, an overwhelming amount of available options frequently causes users to experience difficulty in selecting a movie to view. Secondly, the process of identifying content that aligns with their interests can be dizzying. Lastly, users typically receive specifically movie recommendations that are genuinely reflected in what they want. So this obstacle highlights the importance of a stable recommendation system that can help users make less rush exploring options. In order to address these three challenges that I explained earlier, our group has set up the three main objectives too. The first objective is to determine the user's general and mood preferences. By identifying these two preferences, we can customize recommendations to more effectively meet the preference of each individual. The second objective is to develop personalized movie recommendations through the use of content-based filtering. This method guarantees that the suggestions are appropriate and closely aligned with the user's viewing history. The third and final objective is to assess the accuracy and effectiveness of our recommendation system by evaluating the personalized movie recommendation using the F1 score.
Hello, my name is NURUL Nabilah. Now I will be presenting about the scope of movie recommendation system. So the first one is about dataset. The dataset that we use for this system is actually the MDB movie dataset is from Kaggle and have various features such as budget, runtime, keyword, genre, and we also have added new attribute which is mood that can be categorized in 5 different emotions. The first one is happy, calm, sad, and also angry and excited. Now is about model. The model approach for our movie recommendation utilize is content-based filtering and have a TF-IDF vectorization and also concise summary to capture the textual data for movie description effectively. And then the last one is the evaluation, which is using the F1 score to measure the effectiveness for our recommendations. For the significance of our movie recommendation system consists of 4, which is the first one is technology advancement. That our system will be utilize the machine learning technique to solve the real-life scenario and complex problems. So this can demonstrate the power of versatility of machine learning in practical application. The next one is learning opportunities. By developing this movie recommendation algorithm, it can make our more understanding to how this recommendation engine is working. And then the third one is important of personalization. Is to producing accurate recommendation based on user preference. So it can showcase that how this personalization experience can enhance user satisfaction by using this movie recommendation. And then the last one is impact on the movie industry. So our recommendation system can enhance the user loyalty and engagement for content provider and platform owner. So by increased user retention satisfaction, it ultimately contributes to the growth and success of industry entertainment.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nabil and I'm going to talk on the coding part of this project. So as mentioned, this project leverages machine learning technique to enhance user experience by providing personalized movie recommendation based on mood and genre. So we basically use content-based filtering combined with TF-IDF and constant similarity to develop our movie recommender system. So we start off by loading the MD movie dataset from Kaggle to perform data cleansing, which is used to handle missing value and ensure a good data quality for this recommender system. So next, we create a new column called combined features from the keyword column. This helps in capturing the nuances of movie description using the FIDF. Now, let's move into the core of our project, which is the recommendation functions. So, this function basically filters movie based on the user mode and genre, calculate the constant similarity between movie descriptions, and rank the recommendation by combining the similarity score with movie ratings. We start by defining a function called recommend movie that takes 4 input, the user modes, genre, the data frame, and the DFIDF matrix. We then filter the movie in the data frame to match the specified mode. This is done by converting both the mode column and the input modes to lowercase for case insensitive mesh. Next, we filter the movie to also match the specified genre. So this is achieved by checking if any of the genre are present in the movie genre list. If no match the specified mood and genre, the function returns a message indicating that no suitable movie were found. We then obtain the indices of the movie that match the modes and genre, and check if the indices are within the bound of the TF-IDF metric to avoid any out of range errors. We then calculate the constant similarity between all movie and filter mode and genre specific movie. This measures how similar each movie is to the specified one. We compute the average similarity score for each movie by averaging the constant similarity score and combine this average similarity score with the movie rating to prioritize higher rated movie. We sort this combined score and retrieve the top 10 movie with the highest score. We extract the titles and rating of this top 10 movie and sort them by rating in descending order. Thus, the function then return the top movie recommendation based on the specified moods and genre.
Now I will explain the continue codes from Nabil. So here the presented code is for to design interact with user, which is the user need to enter the preferred mood and genre. And then the other code is about to display the recommendation by listing the top recommended movie along with their ratings. Next function is to evaluate the recommendation system by using cross-validation. So here have a code that where the keyword cross-validation is initialized with file split shuffling the data before and splitting, and then the data is split into training and testing set for each float. The corresponding row are selected from the TF-IDF matrix, and the lists are created to store the true and predictive mode for the test sets. This section code is actually for to compute the constant similarity with the training set, and then have an average similarity score based on each mode, and then have a codes to define the highest similarity score is predicted and added to the list of predicted modes. The last section of this algorithm part is to calculate the F1 score and accuracy for the current floats and append it to the respective list, and have a evaluate underscore function system is called to evaluate the recommendation system. And the last one is going to print the F1 score and also the accuracy.
Now, let's move on to the result of our project. The system generated a list of highly recommended movies based on user input regarding their mood and preferred genre. For example, when the user select the happy mood and select comedy as the genre, the system suggests a highly rated movie such as Gabriel's Inferno Part 2 and Justice League Dark Apocalypse War. Constant similarity scores were calculated for each movie using keyword TF-IDF vector, which were used to rank the movie based on their relevance to the user's preference, including the movie rating and the ranking process improved recommendation, aligning them with the user rating and preference. The movie recommendation system was assessed using significant variable, resulting in an average accuracy of 47.5%. This suggests that almost half of the recommendation made were accurate. Additionally, the F1 score was calculated to measure the balance between accuracy and recall. The model achieved an average of F1 score of 0.4812, indicating a moderate balance between incorrectly recommended movie and misrelevant movies. Now, I will explain the discussion of our project. The model has effectively integrated mood and genre to provide personalized movie recommendations. Utilizing the word average attribute as a rating has enhanced the recommendation result. The F1 score and accuracy provide similar result, indicating consistent model performance in identifying movies. Next, the filtering mechanism successfully categorized the movie dataset to generate recommendation aligned with the user's mood and selected genre. However, some combination of attributes result in no recommendation, highlighting a limitation of the dataset in fully capturing user preferences. Next, data pre-processing, including data cleansing and transformation, ensure that the raw data used in making recommendation is suitable and consistent for the machine learning model. Feature engineering of command feature from the keyword column helps to understand the fully context of movie description for TF-IDF vectorization. Finally, there are some limitations to our approach. The input may not find any related result due to lack of data within the dataset. Mood classification based on keywords may not fully capture the user's emotions, suggesting the need for additional attribute to provide a complete insight into user preferences. The current attribute, mood, and keywords may not be strong enough alone, indicating the need for more comprehensive participation of other attributes for accurate recommendations.
To improve and enhance the recommendation system, it is essential to expand the datasets. This can be achieved by integrating additional movie database or continuously updating the dataset with new release. By having a broader dataset, the system is expected to offer more comprehensive recommendations covering a wide range of mood and genre. Other than that, combining content-based filtering with collaborative filtering can create a robust hybrid filtering recommendation system. This approach leverages both movie content features and the user behavior data to increase the accuracy of personalized recommendation. So by using both techniques, the system can provide more relevant and precise suggestions, and also personalized recommendations. The last one is by incorporating an advanced natural language processing technique, NLP, such as sentiment analysis and contextual embedding models like BERT or GPT. It can significantly enhance the mood classification accuracy. This technique provides a nuanced understanding of movie descriptions, leading to more accurate mood categorizations and personalized suggestions. In conclusions, this project has showcased machine learning technique in creating a robust movie recommendation system using the Kaggle TMDB movie dataset. The system accurately captured movie description and provided recommendation based on movie moods and genre. This highlights the practical application of machine learning in enhancing the user experience and engagement in the entertainment industry. So by implementing data processing and feature engineering, the system effectively utilized the FIDF to understand movie descriptions. The consistent performance of the model, as indicated by evaluation, underscore its effectiveness and reliability. So I guess that's all from us. Thank you.